Layered Insight is the industry's first embedded security approach for containers. Trusted by Global 1000 enterprises to secure their containerized applications, it's the only solution that requires no root privileges, has zero dependency on the underlying infrastructure, and is fully portable across any container environment. Unified DevOps and SecOps, enabling the rapid development of containerized applications without worrying about security. To learn more, please visit layeredinsight.com/ASW. Rapid7 powers the practice of SecOps. Using shared data, analytics, and automated workflows, SecOps unites IT, DevOps, and security teams to make security an outcome of innovation. Rapid7 combines technology, expertise, and advocacy to drive vulnerability management, application security, incident detection, and log management for more than 7,000 organizations worldwide. Power up your SecOps practice with a free trial at rapid7.com/securityweekly. Hard-coded credentials can be trouble, but not as much trouble as a vulnerable DevOps environment. If you want protection without the hassle of security slowing you down, CyberArk, the #1 provider in privilege access security, has the solution for you. With CyberArk Conjure, developers can easily secure secrets across any DevOps toolchain or platform, whether your application runs in the cloud or on premises. Eliminate the headaches of managing secrets and try Conjure open source for free with no strings attached. Visit conjure.org/ASW to get started today. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW.
Welcome back, everyone, to Application Security Weekly. This is the news for the week of May 13th. Sorry, I had to look at my calendar there. So one of the things I wanted to cover quickly is I didn't put it in the show notes. I got to go back and re-add it. But TrustWave just came out with some interesting information about the vulnerability we talked about a couple of weeks ago in Electron, which is CVE 2018-1000, so 1000136. Talking about the node integration and a good write-up on this. So yeah, the fact that, today Electron is building things like Slack, VS Code, I don't know, probably a bunch of other things that I'm not even thinking about right now.
Is it now? What is Electron, Keith? Is that like Node.js? Is that like it's JavaScript, right? Or no?
Yeah. So it's a JavaScript framework for native application development for your desktop. So the way that it works is effectively you can write up your whole application in JavaScript, and then you can stub out certain calls that JavaScript as like a browser, because it all kind of sits on top of Chromium, right? It uses the V8 engine. Mm-hmm. You have to stub out certain function calls. So you can actually stub them out and then have them call things like C program language to actually then do a compiled binary of like C. So if you want to do a proxy, for example, in Electron, you'd have to use C's, the C programming language's proxy functionality stubbed out inside of a JavaScript call with an Electron.
Gotcha.
So it's a framework that allows you to develop native applications that can work across operating systems very, very easily. And
are you bundling? So like when I download Slack or VS Code, is there a browser engine included in that download?
I don't know that there's necessarily the engine included in the download. I think it makes use of the Chrome or Chromium's engine itself that's on your system already.
If you have Chrome.
Yeah, if you have Chrome, I guess. I mean, I guess if you didn't, maybe there is like an additional install that's readily available as like a backup to it.
Okay.
But to that end, what's interesting about this is because it is ubiquitous, right? Like it's able to be used across all three platforms. Getting remote code execution in the framework, so in the Electron framework itself, is a problem because now, as long as you know Bash or PowerShell or well, I guess still Bash if you're on MacBook or Mac OS, you can basically just make remote code execution calls to the Electron app and then get the same level access as the application, which usually tends to be a high level access. Not always, but in most cases it is. So the write-up by TrustWave that I'm going to actually add into the show notes here is pretty good. It's the Spider Labs blog on this, and it actually goes into like the functional level code as to what the problem is. Any additional questions about that, Paul, before we jump into maybe some of the other stories we have?
Nope. I'm just reading, looking at the headline about Uber's self-driving car.
Yeah, that was interesting because I know that it happened a few weeks ago. We talked about it briefly on Paul Security Weekly, I think last week. But the thing that I found interesting about this is kind of a postmortem, and I don't mean that to be punny because someone actually died in this situation. But
I know I made a pun on the last Paul Security Weekly, and I apologize for that. It was too soon.
Yeah, it really is one of those things where it's a tragic accident, quite frankly. But they talk specifically about how this all came about. And so the woman who died was Elaine Herzberg in Tempe, Arizona, back in March. What ended up happening was the sensors on the car, even though it did detect that she was in front of the car, it determined that she was effectively a false positive. And so this article, I think, had a very even-handed discussion about the problem set, which is that software needs to detect objects like cars, pedestrians, rocks, etc., to potentially avoid them if they're actually a true positive. But the problem is that there are things like a plastic bag or perhaps a trash can on the side of the road that aren't really, you don't terribly have to worry about them when it comes to driving, right? You can kind of just keep going. And in effect, the way that the software is written is so that the rider in the car has a positive experience, which, by the way, is ultimately what leads to the sort of problem that occurred, which is you get a false positive and then you hit somebody or something as a result. Because if you were too strict on the detection mechanism and you hit the brakes for every little thing, the rider would be getting whiplash.
Well, and my concern too is how to differentiate between small dogs, children, and adults, different from there's some other kind of object like a garbage can that blew, like this is common, right? On garbage day, after all the trash is picked up, it gets windy, garbage can ends up in the road. How does the sensor then differentiate between a living thing and the garbage can, right? And that can be very difficult with the sensors that they might put on a car. And of course, your false positive has very negative consequences, obviously. We talked about this actually when we did an interview with our RF something company I can never remember the name of, that uses radio frequency waves to identify objects outside of a physical perimeter of a building, and they're able to determine based on movement and the reflection back from the radio waves if something is in fact a drone or a bird, right? Because they behave differently and they can do that level of detection. I'd imagine the same kind of machine learning and to a certain extent artificial intelligence has to be built into the cars. It'd be a kind of a cool thing to merge that technology, such that they're sending out some kind of signal, receiving it back to enumerate objects that are in front of them, make the determination, is it something I need to stop for or I don't? I would imagine now the software is probably going to err more on the side of caution than not, because again, how do you differentiate between living animals and something that's not, because it can still be moving in the street?
And to that end, it's one of those situations as well where I think that there will be a few different phases of release for automatic driving vehicles, right? I don't know exactly the layout of Tempe, Arizona in terms of being a city or a town, for example.
Right.
But I can foresee this being the sort of thing that Tesla has already kind of done this today, which is you can use kind of the autopilot functionality on things like major highways, right? Where you don't expect to have things other than a car or an animal. You don't expect to see people, bicycles, small children. And so to that end, there's probably a middle path here, which is to say that for the time being, using a car in a low speed environment where it's easy to brake, and it's not necessarily going to brake quickly in a way that actually hurts the rider of the vehicle, you could probably err more on the side of caution and be a little bit more cautious in the way that it drives through a city, right? Now, if you get out into a suburb, on the other hand, that is just rife for problems because it's generally a faster speed limit, but it's also one of those situations where you probably have more children or animals, pets, and generally just people, right? People walking around.
Well, yeah, I mean, but it's an AI problem. I mean, there are security ramifications, right? What if someone's able to disrupt that subsystem? But it's an AI problem because as a human, when you see a ball go out in front of your car, you know that Likely there's a child that's going to follow, and when you see the ball, you know from being trained as a driver that you have to slow down and or stop. How do you train software to do, and obviously there are ways in artificial intelligence, but in this case, it literally is a life or death situation. And if there is no human operator or no human override, it has to be completely autonomous, which is kind of scary for me. As in all of us that know software, right? That's kind of scary.
Yeah, yeah, and to that end as well, it's a situation where I think part of the solution to that problem, Paul, will ultimately rely on the on-board or the in-car tech being fast enough to make those computations and come to correct answers quickly, right? So the tech today is good. I mean, it's at the point where they can actually, do this sort of thing and test it, but in a way, it's going to need to get faster and more efficient in order for it to truly be able to get that level of learning and that level of knowledge into the car itself. So we're probably like 5 years off from that, I would think. I mean, just given some of the recent announcements in chipset development, but we're not there yet. Is probably what I would have to say. And I think Johnny's saying, was it Logan Harris from Spotter RF?
Yes, thanks, Johnny Blaze.
Yeah, he's on it. So
what else we got?
I was gonna say, moving on. So it looks like Apple has a text bombs effect where, yet again, WhatsApp and iMessage are now falling prey to Unicode characters, where if you click on the black dot of death, you'll ultimately end up losing your phone's connectivity. Basically, it will quote unquote die. You just got to restart it. So I don't know. I mean, here we are talking about self-driving cars, and yet we still haven't solved the Unicode problem. Any thoughts there, Paul?
Well, it's interesting. I've seen a lot of issues with specifically iOS and its receiving messages and have those cause some type of either denial of service condition or some other security problem. I've seen some of these widely publicized. I've seen other ones where it's kind of like an underground, like they're not reporting it to Apple or really even posting, like you just kind of stumble across it and you're like, wow, that's an issue. Like if I send someone this text message and they open it or click on something in the text message, their phone locks up kind of thing. I'm not sure how devastating some of those attacks could be, how far someone could take it, but there's certainly been a track record of those issues happening specifically on iOS, which tells me the code that's receiving messages definitely has flaws. And I think this really goes back to a fundamental programming problem of, parsing, and also even deeper than that, being able to work with different character sets and displaying those character sets properly certainly has been the root cause, in that type of issue. That's pretty big in when you're writing code. I got to take it into account this format or that format. I see it in our own Python application. If you're copying and pasting text and you paste in some funky Unicode characters like, internal server error or some heinous Python error because you're not catching all those exceptions. It's kind of interesting. We see a similar problem with, very commercial with thousands of developers, on the team or more. We still see the same kind of issues.
Yeah, and to that end, it's one of those situations where it's a markets of scale problem, right? Because if all you were doing was, say, a market in China and a market in the US, and you only used English and Chinese characters, you're good. But the fact that you are in so many markets around the world, you end up running into that problem of trying to serve them all, and the code that you originally built was not designed to serve them all. So. Yeah, it'll be interesting to see, when they eventually kind of go back and refactor that set of code. I did want to move on to another story, though, under the bugs, breaches, and more. It's number 3, which is remote rowhammer, also being called as throwhammer, is a new white paper that just came out. What was interesting about this to me is when I was taking classes at University of New Hampshire, I worked at the UNH Interoperability Lab, or IOL, and I worked specifically in their remote direct memory access kind of suite of testing that they were doing. And as it turns out, these researchers at University of Cyprus found that if they were using said systems that had remote direct memory access enabled and were working in that kind of environment, they could remotely perform rowhammer attacks against the servers. So they could do bit flipping at will of a remote server just because of this remote direct memory access technology. I thought this was really cool and kind of scary because they could do it over the local area network. So you still got to get onto the network to begin with. But knowing what I know about the kinds of companies and organizations that are using remote direct memory access kind of scary, because it's probably something that's actually being used out in the cloud all over the place. Paul, what questions do you have about this story? I'm happy to answer any questions you might have on remote direct memory access, because when I was encountering it, it sounded like a bad idea.
Yeah, but I thought, I don't remember the Rowhammer attack, to be honest with you. What's the difference between local and remote in the context of this attack?
Sure. So for the Rowhammer attack, as it started, was effectively bit flipping on DRAM so that you could get a bit of memory to change, which would allow you possibly to change like provisions, like permissions, or even the way that a bit of code is operating. So the local aspect of Rowhammer was you had to effectively get malware onto the system and then execute code to then try to escalate privilege via, basically brooding memory, so that if you figured out where in memory you were for your code and where the memory is that you wanted to get access to, you could flip bits to effectively change the underlying code that was running in that memory sector that would maybe allow you to execute remote code or escalate your own internal privilege on your process so that you could then take that attack further. But you had to first get malware on the device.
Right.
Now, the remote aspect to this is it's using a technology called remote direct memory access, or RDMA. Now, RDMA is used in cloud environments. It's used in high frequency trading. It's used in aerospace, companies doing data analytics. And the way that it works effectively is you kind of have like a server master and then a bunch of clients. And what you can do is you can allocate memory on other clients, so other servers in your rack, to say, I am anticipating a bunch of data. I would like to send you a bunch of data or information to store in your memory that we can then write off to external storage. In fact, my Twitter profile picture is one of those network access storage devices inside of that remote direct memory access lab that I was working in. So it was a 4-foot by 4-foot NAS that we called Dexter for Dexter's Laboratory. So my Twitter picture is exactly that NAS, and why I have the headgear on is because it was loud. So to that end, what they figured out is if I can get my server to tell a bunch of clients, hey, I'm going to be passing things over to your memory to then offload to storage, I need you to set up to be a client. There's no like security protocol here. If RDMA is basically turned on by default, or at least when I was working in it, there was no security protocols here. So if I can just say, hey, I'm going to allocate a bunch of stuff to your memory, and it doesn't go through the CPU, it doesn't go through any other sort of profiling, it goes directly into the memory of that device, I can now perform Rowhammer attacks across the network using this kind of server client architecture, which means that if I'm in a cloud environment, I can change bits on somebody else's server running different processes that may in fact allocate or allow me to then start messing around with the server environment itself, which is all kinds of bad. So,
and what's the fix for this?
Ultimately, it ends up coming down to the hardware level, right? So if RDMA is a situation where the technology is intended to work, that you can allocate memory across your environment, there are certain types of RAM. I don't know if it's DRAM4. I'm trying to recall exactly what it is now, but there are certain types of memory that are not vulnerable to this type of attack just because of the resilience of those bits that are being held in the RAM itself, and the actual chip. Or chips, I should say, on the RAM sticks. So, it's one of those situations where the only fix is to replace your hardware, and the hardware that can, is resilient to this type of attack is pretty expensive. So when you're in a server environment or a server cluster, you're not buying the most expensive RAM for every server. You just want it to be fast enough to be able to accept information and then offload it to disk. It's basically you're screwed if somebody gets into your environment. You've got RDMA, and they can intelligently Rowhammer your devices. So moving on, I did want to cover one story under the "If you build it, they will come" section, which is Mark Russinovich, CTO of Microsoft Azure, was speaking last week about confidential cloud in the Azure environment, which I thought was pretty cool because they're going the way of trusted execution environments, or TEE as they refer to it, which is incredibly important, especially in this situation that we just talked about, right? Where you need to be able to execute code, securely.
We need to execute only your own code and not someone else's.
Yes, that's the other
kind of the
thing as
point.
well. And well, so in cloud environments, it tells you that Microsoft is thinking about this at a level where you can't even necessarily trust the hardware, right? So one of the first things that they talk about is the hardware that they've brought in is Intel Xeon processors with SGX technology in the East Azure region, or East US Azure region, which has got hardware-based features and functionality that allow you to make sure you're executing only your own code inside of that environment, and that there's effectively no visibility into that except for you. You running that you're good, but nobody else can come in and kind of manipulate the code being run in that environment. They've also done some stuff with compute, so talking about managing computer instances and trusted execution environments, again using that Intel Xeon processor technology. Developments, so in terms of API, so trying to build out API security. Attestation, which I thought was interesting, which is verifying the identity of the code that's running. And then, of course, looking at services and use cases as well as research. I thought this was a cool story. I don't know, Paul, if you had a chance to read it at all.
I did not. I think we should get Mark Rusinovich back on the show, though. One of our shows.
Absolutely.
Maybe this show.
Absolutely. I would love to talk with them about it, especially with all the stuff that they're doing on Azure Sphere and some other stuff that they're doing in the Azure space. So I know that we're hopefully going to be getting someone for the Azure Sphere team on the show in the near future. So stay tuned for that. Speaking of hardware vulnerabilities, by the way, Paul, I don't know if you caught that in this case, multiple operating system vendors have released security patches after misinterpreting Intel documentation related to Meltdown Inspector. Yet again.
Yeah, it wasn't this Microsoft's kind of excuse for a vulnerability way back. I remember covering a vulnerability from Microsoft, and basically it stemmed from the misinterpretation of the documentation, which, I mean, we talk about RFCs, right, and how they aren't as descriptive as they need to be, and everyone kind of has their slight interpretation of the RFCs, and that problem specifically comes about when you look at the various implementations of your TCP/IP stacks, especially on embedded systems, and like why when you send this packet to that system does it crash, and why when you send it to this system does it send a reset, and why when you send it to that system it gives you nothing back. And it turns out the answer is because that's how the developers interpreted the RFC. And that story just reminded me of this article.
No, that's absolutely the problem that they're actually blaming here is the fact that it was unclear or incomplete documentation. It makes me wonder if they write the documentation in that way, either because they're concerned about other companies coming in and stealing intellectual property because now they understand exactly how it works, or if it's a situation where it's people developing the hardware aren't just building proper documentation. That wouldn't surprise me at all if that was the case.
I also think a likely scenario, at least in my mind, is that if you make the documentation too specific and too limiting as a result, that when you are considering what technology to use, you're like, oh, I don't want to use that because it's oddly specific and it doesn't give me enough flexibility. Whereas if you make it a little less specific, they're like, oh yeah, I can work with that. I can work that in my application. So some of it could be before adoption. I'm not sure. That's just a wild ass guess.
That makes a lot of sense though. In regards to you want it to be open enough that people can interpret it and then run with it, right? So it gives the people that are using your platform the ability to build an edge, right? If they figure out a clever way to perform some sort of task or functionality on your hardware, now they can be competitive in the marketplace, and therefore they end up using all of your hardware for it, which allows you to succeed as well as a business. So yeah, I could see that could be the case. And to that end, what was interesting here, though, is effectively the problem related to debug exceptions in the x86-64 architecture instructions that would allow for a Ring 3 or user space operating system components to make calls down to Ring 0, basically just going from straight user to root on the operating system as a result of the vulnerabilities that existed for Meltdown Inspector. So I think the coolest thing, or the coolest takeaway from this story, though, is that it was like Mac OS, OpenBSD, Windows, and a number of others all cooperated on releasing this patch at the same time, which I thought was a big deal because we saw the debacle of all the patches that just got totally borked at the beginning of the year. This is a good turning point, I think.
Talk to me about DevSecOps flow.
So this is Pete Chestnut from Veracode, who we're hoping to have on here, I think in June.
Okay.
So Pete and I disagree on the term DevOps versus DevSecOps, and he very cleverly puts in the beginning an article by someone else saying that DevSecOps is just a term. I'm sure that Pete and I are going to discuss this deeply when he comes on the show. But what he starts to talk about here is some of the things about thinking about your relationship with development teams, which I thought was poignant because that's what we talked about last week. And also in his experience, just going to conferences, is people saying, well, those developers are doing it wrong, or security keeps slowing us down. And I thought that was kind of the big thing was, what is your relationship like with your development team today? And could it be better? Because if it can be, it probably should be, and you need it to be ultimately to be successful as a security practitioner. Otherwise, you get ignored. The other thing that he talks about here is mutual accountability, which I thought was interesting because he cites basically if they're in charge of developing it, then shouldn't they also be in charge of keeping it secure, or at least responsible for that, or even just a little bit feel accountable for it? And I thought that was a really good point because a lot of the time, and maybe this is why he uses the term DevSecOps, is developers don't feel responsible for security. They're not measured on it. And therefore, it's security's job to build the right architecture, configurations, deployments for them. And I think that that's probably the right way to proceed. But he kind of disagrees with us here in terms of they should be accountable. Therefore, it should be part of the term. It was a good article overall. It's going to be a part one of a 3-part series. I don't know if he's releasing it weekly or bi-weekly, but I imagine we'll follow up on the other 2 parts of the series as well once he's released them.
Yeah, I think it's just quick thought on this article that accountability is kind of like a pyramid in the developer's mind, or like there's a priority, right? Developers, I think, in large part feel accountable to get features delivered out the door. I think they feel accountable to fix functional bugs first because there's a user that maybe can't use some piece of functionality. And I think security kind of falls like last if it's a sheer security issue in the traditional sense, right? And what I think DevOps allows you to do is have them treat all issues in a more equal manner and address problems kind of as you go so that you don't end up with too much technical debt, such that the priority is a little more balanced, that it's about creating reliable software, and whether that issue is a feature, a bug, which arguably sometimes are the same thing, or a security issue, maybe all 3 of those are the same thing, which I guess is my point, is you want to be addressing these issues as you go. And I think that's really the power of DevOps. But in a lot of environments today, like security is way down on the pecking order if it's viewed that way, right? If developers are viewing it, I'm accountable for this, this software getting out, this version getting out. That's what they feel accountable for. I think the accountability needs to extend to, has to go out and work, which is part of that. And security is certainly part of that.
Yeah, it's more of a circle than a pyramid, right? It's what percentage of their responsibility falls into each category as opposed to what are the priorities top down. Right. So yeah, maybe somebody needs to make a DevOps pie chart as opposed to a DevOps pyramid. So anyway, with that, I just want to say there is one commit strip article or comic here at the end, and number 4 for food
and
for thought.
I've lived that, dude. I've done happy dances for times maybe you shouldn't really do happy dances.
Right. It's literally titled Progress. So I think that for those sysadmins and other people out there, they'll enjoy that as well. With that, thank you everyone for joining us this week for another episode of Application Security Weekly. Remember to git commit and stay classy.